All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to learn how to solve quadratic equations by factoring. Okay, we're going to start today's lesson off with a little warm-up. Okay, it's 5 questions long, and we'll knock these out really quickly. So let's get started. The first question asks us to graph this linear equation, y equals 2/3 x minus 4. First, let's recognize that this equation is in the form y equals mx plus b. That's called the slope-intercept form. And when we have the slope-intercept form, we know that m is the slope and that b is the y-intercept. So the slope m equals 2/3. That means that 2 is the rise and 3 is the run. We also know that b is the y-intercept. So the y-intercept, or y-int, is -4. Now, knowing that allows us to graph a line on this coordinate plane. So the first thing we do is we find -4 on the y-axis. Here it is right here, -4. I'll put a big blue dot right there. And now I'm going to use the rise over the run to find another point. So I'll go starting at this y-intercept with my pen. I will go up 2, 1, 2, and then to the right 3 spaces. 1, 2, 3. And I'll put a dot right there. Okay, so now that I have 2 points on a coordinate plane, I can connect them with a straight edge. And you really should have a straight edge to do this. You can use your student ID or a credit card or anything that's straight, a ruler, and you draw a line passing through those 2 points. Okay, so that is the line. And we want to label this line y equals 2/3 x minus 4. That's it for number 1. Number 2, we're asked to simplify a radical expression. So we're given the square root of 24, and there's a hint here, prime factor 24. And that's exactly what we need to do. The very first thing we need to do is write down 24 just like this here, and then draw a little branching tree beneath it. Now what I'm looking for is the smallest prime number that 24 can divide evenly into. Just a quick reminder, prime numbers start at 2, and then it goes to 3, then 5, then 7, then 11, then 13, then 17, and so on. And the way that we're coming up with these numbers is that they can only be divided by themselves and 1. That's what makes them a prime number. So the smallest prime number 24 can be divided evenly into is 2. Okay, now we're looking for the partner that goes with 2, and that's the thing that would multiply by 2 to get 24. So that would be 2 times 12. 2 times 12 is 24. Okay, but 12 is not a prime number. So we have to break it down now. And now again, I'm looking for the smallest prime number that 12 can be divided evenly into, and that would be 2. And its partner there is 6, because 2 times 6 is 12. But 6 is not a prime number, so I'll break it down into 2 times 3. Okay, so now I've broken 24 down into prime numbers. So what I want to do next is rewrite this square root thing, but I want to rewrite it and make it really long like this. Okay? And what I'm going to do is instead of writing 24 inside the square root symbol, I'm going to write the product of each of these prime numbers multiplied together. So it'll look like this. 2 times 2 times 2 times 3. Okay, so far so good. 2 times 2 is 4, times 2 is 8, times 3 is 24. It's still 24 underneath the square root symbol. The next step is to group these into pairs. Okay, so I see I've got a pair of 2's, and that's the only pair I have. Now, quick reminder, 2 times 2, of course it equals 4, but we can also write it as 2 squared. Okay, and that's what I'm going to do here. So for the next step, we'll rewrite that square root. But instead of writing this 2 times 2 right here, I'll write 2 squared times 2 times 3. Oh, we're moving right along. Now, something to remember here is that I'm able to break up this square root if it's all multiplied underneath the square root. What I can do is rewrite this as the square root of 2 squared times the square root of 2 times 3. Okay, 2 times 3 is 6, but I'll still write it 2 times 3. All I did was break apart that square root. Okay, now the square root of 2 squared is just 2. Okay, so I'll rewrite this as 2 times the square root of 2 times 3. Well, 2 times 3 is 6, so I'll just write a 6 there. And to finish it off, I don't need to put this little dot. This all simplifies down to 2 square root 6. Okay? So that is how you do number 2. Number 3. Take a look at this for a moment. Okay, we're asked to sketch the solution to a system of inequalities. Here I've got these inequality symbols. These are both less than symbols. Quick reminder, a less than symbol, like that, means that I will have a dotted line and open circles. And when I shade, I will be shading below the line. Okay, because it's less than. So with that in mind, we're going to graph both of these as though they were lines. Now, they are in slope-intercept form, and the one thing you need to know is that hiding right in front of this x is a little invisible 1. So we'll start with the first equation. I have a slope of 1. That means the rise is 1 and the run is 1. And I have a y-intercept at -3. So remembering, I'm going to put an open circle. I'll go down to -3 on the y-axis and put an open circle right there at -3. Now I'm going to use my rise over run to plot in some more points, and I'll plot in more than one of them. So I'll go up 1 over 1, put an open circle. Up 1 over 1, put an open circle, just like that. You see how I'm forming this pattern here that would go up. And now I can connect all these open circles with a straight edge, and I'm going to put a dashed line, okay, because it's less than. If it were less than or equal to, I could put a solid line, but it's just less than, so I have to put a dashed line, just like this. Now I have a dashed line passing through those points, and that is the inequality y is less than x minus 3. I haven't shaded it yet. We'll do that later. Now I'll plot in this second inequality. So in here, I have a slope of -3. Okay, that means I will, wherever my y-intercept is, I'll start there and then I'll go down 3 over 1. So this, instead of rise over run, this is like fall over run. You fall 3, you run 1. And I'm starting here at a y-intercept of 1. So remember, it's a less than symbol, so I'll use open circles and dashed lines. And I'll start here at the y-intercept of 1 and put an open circle right there. Okay, so now what I need to do is go down 3 over 1. So I'll start at that open circle and go down 1, 2, 3 over 1. Okay, I'm actually going to be drawing an open circle right over one of my blue open circles. So I'll plot another one. Starting at that new open circle there, I'll go down 3, 1, 2, 3, over 1, open circle right there. Now I can connect those red open circles using a straight edge, and I'm going to dash in a line. Dash, 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 dash. Dash in that line because it's less than. If it had been less than or equal to, I could have used a solid line. So now I have my inequalities graphed in, and all that remains is for me to shade. So let's think about this for a moment. I'm going to be shading below both of my dashed lines, but I only want to shade in that region where both of them would be shaded. So here, beneath this red dotted line, I would shade everything down here below the line and to the left, everything. Beneath this blue line, I would shade in blue, if I was going to do it, everything below the blue line and to the right, okay? Notice that there's only one place or one region of this graph where I would shade both of my inequalities, and that would be in here, in this region right here. So I'll take a green color, could take any color, but I'll take a green color, and I'm going to shade in this region down in here. Okay, just like that. Okay, so now I've shaded that region down in there. And that's all you do for that problem. Number 4, find the distance x. And here I'm saying just write the function. This is trigonometry. What we are given is an angle of 25 degrees, and we are given a radius or a hypotenuse of 12. For my students that remember me talking about this last year, remember that the hypotenuse of any, I should note that this is a right triangle, the hypotenuse of any triangle is actually the radius of a circle. So just as a little curiosity here, what I can do, just so you kind of see what's going on, is I can take a compass like this, place the tip at the beginning right there, and make the diameter of the compass to be the hypotenuse length. So watch this. Okay, I'm really working here with a circle. Just something interesting to think about. Now, we are asked to find out what this height is here, x. Now remember that we have this little mnemonic device called SOH, S-O-H, Ka, C-A-H, TOA, T-O-A. And what this mnemonic device tells us is that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what I'm dealing with here in this problem is the opposite and the hypotenuse. So if I were going to find out what this height was, I could say that because I'm dealing with the height here, I'm dealing with the opposite side, so I would use the sine function. And what I would say is the radius of this circle, r, times the sine of 25 degrees is equal to the opposite over the adjacent, x over 12. And here I realized I made a slight mistake. We don't need to write this r right here. I was jumping the gun a little bit. So it's just sine of 25 degrees. Sine of 25 degrees is equal to the opposite over the adjacent. You'll see why I meant I was jumping the gun here in a moment. So in order to get x by itself, I need to multiply both sides of the equation by this denominator of 12. Okay? Now the reason I did that is because I want to get x by itself, and I can cancel out those 12s on the right. Now on the left, all that remains is 12 times the sine of 25. So what that means is that 12 times the sine of 25 degrees equals x, or the height. Now, that's all I wanted you to do, because to do the rest of it, you would need a calculator. Well, I have a calculator here, and I've put it into degree mode. That's something you would need to do. Let's find out what that height really is. So let's take 12 times the sine of 25 degrees. And it tells us here that the height x here would be 5.071419141. But we don't need to do that. We just wanted to find out what this is right here. This would be the answer that I was looking for here, where you just set it up. There it is. Okay? So finally, we're down to number 5. Find the distance between 2, 0 and -4, -3. I'll let you look at that for a moment. We're going to be using the distance formula to do this. Okay, so the first thing we need to do is label these points. Okay, so the first thing I'm going to do is label 2 as x1 and 0 as y1. And then -4, I'll label that as x2. And -3, I'll label that as y2. Once we have those labeled, we can just plug them into the distance formula. Okay, so let's write d equals, okay, big, long square root symbol, straight edge, strongly preferred. Okay, open parentheses, and we're just going to fill it in. x2 is -4 minus x1, which is 2, close parentheses, squared, plus, open parentheses, y2, which is -3, minus y1, which is 0. And that will also be squared. Okay? So let's continue to simplify this. We'll just write another square root symbol and put that equal here. And I'll write that, clear that out right here. Big square root symbol. Open parentheses. Now, -4 minus 2 is -6. Okay, and that will be squared. Plus, open parentheses, -3 minus 0 is -3 squared. Okay, so we're just going to perform these little operations now in our next iteration. Okay, negative 6 times negative 6 is positive 36. So negative 6 squared is 36. Plus negative 3 times negative 3 is positive 9. And negative 3 squared would be then positive 9. So I have here plus 9. Now we need to do 36 plus 9. Well, 36 plus 9 would be 45. So what the current state of the problem is now square root of 45. But we can simplify that. We don't want to leave it as a square root of 45. It can be simplified further. And the way that I'm going to simplify it is just like I simplified it up here in problem number 2. I'm going to prime factor 45. So I'll go over here with some side work and put 45. And now what I need to do is think of the smallest prime number that 45 can be divided evenly into. Now it's an odd number, so it won't be 2. So we go up to 3. We want to check and see, is 45 divisible by 3? Well, there's a quick trick that you want to learn here. Look at 45 and add up the digits. 4 plus 5. 4 plus 5 is 9. 9 is divisible by 3, therefore 45 must be divisible by 3. So the first prime factor is 3. 3 times 15 is 45. But 15 is not prime, so I need to prime factor 15. And the smallest prime factor again would be 3 and then 5. Okay? So what I'll do is now, instead of writing square root of 45, I'll write square root of, and then a longer square root symbol here, the product of the prime numbers. So instead of writing 45 under the square root symbol, I'll write 3 times 3 times 5. Okay? Now what I'll do next is group the 3's together. And recall that 3 times 3 can be written as 3 squared. Okay, so now the next line says square root of 3 squared times 5. Okay, now recall that I can break up this square root by its products. So what I'll do is equals square root of 3 squared times square root of 5. Now the square root of 3 squared is just 3. So I can write equals 3, and then the square root of 5 we leave as a square root of 5, so I'll just write square root 5. Okay, so this whole distance right here between 2 comma 0 and negative 4 comma negative 3 is just 3 square root 5. Okay, and that is the complete warm-up. It's a good broad overview of Algebra 1, Geometry, and some Algebra 2. Okay, now on to the main topic of the day, how to solve quadratic equations by factoring. Now I say here, before we start, let's review what a quadratic equation is. Well, it looks like a horseshoe. Okay, so it can be a horseshoe pointing up. That means it has a positive slope. It can be a horseshoe pointing down. That means it has a negative slope. What it can't be is a horseshoe pointing sideways, because like this one right here, it's not a quadratic equation because it fails the vertical line test. And I should be more specific here, it's not an example of a quadratic function because it fails the vertical line test. So these are the two kinds we'll be working with most often. Some more facts about quadratics. The equations will always have a squared term, and here are some examples of quadratic equations with that squared term in there. The squared term will be the largest exponent. Anything bigger and it wouldn't be called a quadratic. So it's going to be x squared, 3x squared, x squared. All right, so that's something else. And the next fact is that it has exactly 2 solutions. So here I've gone ahead and factored a quadratic and solved it. and graphed it. Okay, so here I have two solutions, and I'll show you how to do this factoring in a minute. But I have two solutions, x equals -3 and x equals -1. And I have plotted those here on a little graph, and you see that these numbers, -3 and -1, correspond to where this quadratic function or graph or equation crosses the x-axis. Now, it doesn't always have to cross the x-axis, but when you do get these x values like this, that's where it crosses the x-axis. Those are the solutions to the quadratic equation. So we take a quadratic equation and we factor it. We set those factors equal to 0, and then we solve for x or whatever letter it is. Okay? Quadratic equations also have an axis of symmetry. Here I have drawn a dotted blue line that cuts that shape perfectly in half. Okay, so it's an axis of symmetry where either side of the shape is identical to the other side, just reflected. Okay, like a butterfly. Okay, next thing to notice is that every quadratic equation, when graphed, will have a vertex. That vertex will either represent a maximum or a minimum point. So you see in our example here, we have a vertex at -2, -1, and that represents a minimum. Okay? As you can see, quadratic equations have many properties, including many not listed here, but this gives you some of the basics. Now, let's learn how to factor one of these things. Move on to the next page. Okay. Today we're going to learn how to solve quadratic equations using a technique called factoring. Now, there are many different factoring methods, but we will start with the simple case of factoring. Now, for this simple case, you can only use this method when the quadratic equation has a leading coefficient of 1. Here's an example. X squared minus 9x plus 14 can be factored using this method because there is an invisible 1 in front of the x squared, right here. Okay? If it was any other number than 1, then this method would not be possible. Let's look at that example and solve it by factoring. So, given y equals x squared minus 9x plus 14, solve by factoring. Now, what we want to do is break down this quadratic into two smaller pieces called binomials. Binomial because they have two parts. So we need to find two numbers that add to equal the middle coefficient of -9 and multiply to equal the last term of 14. Okay, so what I'm looking for are two numbers that add together to equal this middle coefficient and multiply together to equal the last term of 14. Here's how to set that up. Okay, so I've rewritten y equals x squared minus 9x plus 14. And I have drawn these open parentheses, close parentheses, open parentheses, close parentheses. I'm going to put an x in each one on the left side toward the left parentheses there. And then I'll create this little table. Okay, and I want to fill in this little table. I have a line and then a plus sign, then a line equals -9. Line times symbol, line equals 14. What I'm looking for are two numbers that add together to be -9. And those same two numbers can be multiplied together to give me positive 14. And here I see that those two numbers are -7 and -2. Because -7 plus -2 equals -9. -7 times -2 equals positive 14. So that's how I know I'm right. So I just take those numbers and I stick them here into these binomials. So now I have x minus 7 and x minus 2. That's all there is to factoring using this simple method. Okay? Now, notice this. Whenever we factor something, we should always be able to multiply our binomials back together to get our original quadratic equation using a method called FOIL. Okay? FOIL stands for first, outer, inner, last. And what I've done here is I've taken our two factors, x minus 7 and x minus 2. Those are called factors. And I have applied FOIL to it. So first I've done the first term, x times x is x squared. The outer term, negative 2 times x, is negative 2x. The inner term, negative 7 times x, is negative 7x. Finally, the last term, negative 7 times negative 2, is positive 14. Okay? So then I'll rewrite all these things I've circled. X squared minus 2x minus 7x plus 14, and combine these like terms here in the middle. And I've got negative 2x minus 7x is negative 9x. So the original quadratic emerges, x squared minus 9x plus 14. So now that we have our factors, x minus 7 and x minus 2, we can finally solve this quadratic equation. Okay? On the previous page, we factored y equals x squared minus 9x plus 14 to find that y equals, and then I've got my two factors, x minus 7 times x minus 2. This is called the factored form of the quadratic equation. Now, to solve this quadratic, we just set each of the factors equal to 0 and solve each little equation for x. So I drop the parentheses and just write the factor x minus 7, set it equal to 0, and solve for x. So I add 7 to both sides and I get x equals 7. Next, I have x minus 2. That was my other factor up here. I set that equal to 0, drop the parentheses there. Now I add 2 to both sides to get x equals 2. So x equals 7 and x equals 2 are the two solutions to our quadratic equation. This means that this equation would cross the x-axis at 7 and 2 if we graphed it. So let's do that. Now I did a little bit more math that we'll learn about later to find the vertex and the axis of symmetry, but I wanted to show you here. So here, this quadratic equation is crossing the x-axis at 2, and over here it's crossing the x-axis at 7. Okay, those were our solutions, 7 and 2. The solutions to quadratic equations are sometimes called zeros because when the equation crosses the x-axis, y is 0. So any number I plot on this x-axis, the y value will be 0. So our solutions here are plotted at 2, 0 and 7, 0. That's why these are sometimes called zeros. Now, these quadratic equations don't always cross the x-axis. They don't have to. Whenever quadratic equations do not cross the x-axis, they still have two solutions, but those solutions are complex or imaginary. So, now that you have seen the whole process, it's your turn. And we'll turn the page here and take a look at a CUDA homework assignment. All right, take a look at this for a moment. All right, so I'm going to help you out here with the first couple of problems. In the first problem, we're given k squared plus 2k minus 48 equals 0. So the first step is to rewrite it. K squared plus 2k minus 48 equals 0. Okay, so the first thing I want to do is do an open parentheses, close parentheses, and then open parentheses, close parentheses. equals 0. Because I'm going to rewrite this quadratic equation in factored form. Now I know that my first term here will be k and k. Because now the leading coefficient is 1. There's a 1 in front of the k squared, so this will work. Now, over here I'm going to set up my template. Something plus something else equals the middle term. The middle coefficient is 2. So I need two numbers that add to be 2. Those same two numbers have to multiply together to give me the last term, negative 48. Okay, negative 48. So let's think of two numbers that multiply together to be negative 48. Okay, right off the top of my head, I'm getting 6 times 8 is 48. So negative 6 times negative 8 would be positive 48, but negative 6 plus 8 would be 2. So you see what I'm trying to do? I'm trying to figure out where I'm going to put this negative sign. What I need is negative 6 and positive 8. Okay, negative 6 and positive 8. Because negative 6 plus 8 is positive 2. Negative 6 times 8 is negative 48. So I'm just going to take these little pieces here and go put them here. K minus 6 and k plus 8. Now, we set each of our factors equal to 0. K minus 6 equals 0. K plus 8 equals 0. And now I will solve for k. So in the first one, I'll do plus 6 on both sides. And I have k equals 6. And over here with this problem, I'll subtract 8 on both sides. And I'll have k equals negative 8. Okay, so these are my two solutions. Okay, for number 2, I have x squared minus x minus 12 equals 0. So I have x squared here. I'm going to rewrite it. Minus x minus 12 equals 0. Now recall that there is a little invisible 1 in front of that x. That's going to be helpful to us in a moment. Write your open parentheses, close parentheses, open parentheses, close parentheses equals 0, and set up your template. I need two numbers that add together to equal the middle coefficient, which is negative 1. And those same two numbers need to multiply together to equal the last term, which is negative 12. Okay, so what can we think of here? I'm thinking of 3 and 4. Okay, so if I do positive 3 and negative 4, and I add them together, I get negative 1. If I multiply 3 times negative 4, I get negative 12. So I have x and x right here, x plus 3 and x minus 4. So now what we do here is we set x plus 3 equal to 0 and x minus 4 equal to 0. So what I'll do here is I'll subtract 3 on both sides, and I'll get x equals negative 3, and that's one of my solutions. For the other problem, I'll have to add 4 on both sides to get x by itself, and now x equals 4. So our two solutions here are x equals negative 3 and x equals 4. Now, I think you all have a good idea of how to do this. This is an 8-question assignment, and you now have 2 of them done. Or sorry, it's a 10-question assignment. You have 2 of them done. And so you just do the other 8 by yourself. Make sure you show your work and that it looks like this work right here. Okay? So if you have any questions, please reach out to me. One way to do that is by looking in the comments section of this video and typing a question down there. You can also send me a message on Remind, send me an email, come talk to me in person. But what I would like you to do is, if you have the ability to, give this video a thumbs up, right? Like this video, because it did take some work to put this together for you, and I would appreciate it if you would acknowledge that. Let me know that this was helpful. We covered a lot of ground today, and I hope that it was all comprehensible. And what we'll do next is we will extend our knowledge and our abilities with factoring to factor more and more complicated quadratic equations. So I really appreciate your attention today. If you have not already, please subscribe to my channel. It's called Athenian Stranger. Just click that subscribe button and then ring that bell so you are always alerted when I release new videos on this channel. Thank you.